You are looking at a bridge disappearing into the ocean, not crossing a river, not spanning a bay, vanishing into open sea and not coming back up for nearly 7 kilometers, then reappearing on the other side, continuing across open water, and landing on an island that did not exist before construction began. 55 kilometers of bridge, tunnel, and artificial land connecting 3 cities that the Pearl River Delta had kept apart for centuries. This is the Hong Kong-Zhuhai-Macau Bridge, the longest sea crossing ever built on Earth. And to build it, China had to solve engineering problems that had never been solved before, in water that didn't cooperate, under a political arrangement that had never been attempted at this scale. Before this structure opened, the journey from Hong Kong to Zhuhai took 4 hours by road, winding around the Pearl River estuary, or roughly an hour by ferry across open water. The bridge cuts that to 30 minutes by car. That is not just a faster commute. That is a complete restructuring of how 70 million people connect, trade, move goods, and think about geography. The Pearl River Delta is one of the most economically productive regions on the planet. Hong Kong on the east bank, Zhuhai and Macau on the west, separated by water and, for most of the 20th century, by political complexity that made a fixed crossing almost unimaginable. This bridge made it real, and the story of how it got built is as much about human stubbornness as it is about engineering. The idea is older than you might expect. In 1983, a Hong Kong developer named Gordon Wu sat in the United States looking at the Chesapeake Bay Bridge Tunnel and had a thought that was simple and enormous at the same time. What if something like that existed in the Pearl River Delta? He pitched the concept to Beijing and Guangdong officials in 1988. The discussions went nowhere. The Tiananmen Square protests of 1989 unsettled investors and collapsed the political atmosphere needed to move a project of that scale forward. For 15 years, the Pearl River kept its gap. Then, in 2003, a formal task force was established and a feasibility study was commissioned. For the first time in the project history, the math was done seriously and it confirmed what everyone already knew. The crossing needed to be built. 6 years of negotiations followed. 3 governments operating under different legal systems, different technical standards, and different ideas about who should pay for what had to agree on every major decision before a single pile was driven. Hong Kong covers its roads on the left. Mainland China and Zhuhai drive on the right. The bridge, which sits technically in Chinese waters for most of its length, uses right-hand traffic. Drivers crossing from Hong Kong switch sides at the boundary crossing facility island before they ever set a wheel on the main span. That single detail, which sounds trivial, required years of legal and engineering discussion to resolve. Everything about this project was like that. Every detail touched a border. By February 2008, the governments of Hong Kong, Macau, and Guangdong had agreed on a cost-sharing arrangement. Hong Kong would cover 50.2% of the main bridge costs, Guangdong 35.1%, and Macau 14.7%, with each jurisdiction responsible for its own boundary crossing facilities and link roads. Construction began on the Chinese side on December 15, 2009. 9 years later, the bridge opened. The total cost across all sections, main bridge, link roads, and boundary crossing facilities, reached the equivalent of approximately $46 billion US. It was the most expensive sea crossing ever built, and it earned that distinction at every stage of construction. Stand at the eastern end of the Pearl River estuary and look west toward Zhuhai. What you are looking at is one of the busiest shipping corridors in Asia. Vessels bound for the ports of Guangzhou and Hong Kong move through this water around the clock, every hour of every day, carrying container cargo, bulk materials, tankers, and everything else that feeds 2 of the largest port systems in the world. Any fixed crossing of the Pearl River estuary had to accommodate that traffic without interruption. The main navigation channel demanded a vertical clearance that no bridge design could economically provide over the length of span required. The engineering answer was to put the crossing underground for the critical section, build a bridge until it reached the shipping lane, go under the sea floor, come back up on the other side, and continue as a bridge again. The result was a 6.7-kilometer immersed tube tunnel sitting 40 meters below the seabed, the longest, deepest immersed tunnel on Earth. And to make the transition from bridge to tunnel and tunnel to bridge, China had to build 4 islands where the Pearl River estuary had only water. The artificial islands are where the project's most audacious engineering decisions were made. The eastern island, closest to Hong Kong, had to appear in one of the most environmentally sensitive stretches of water in the region. The Chinese white dolphin lives here, a species already under pressure from decades of port expansion and shipping traffic. Strict environmental regulations ruled out conventional dredging and seafloor disturbance. Engineers had to build an island without disturbing the seabed ecology below it. The solution was a ring of 220 large steel cylinders, each one 31.5 meters in diameter, driven directly into the seabed without any excavation of the material beneath them. Some cylinders were fabricated on site by welding together 200 flat steel plates per cell. Others were prefabricated elsewhere and towed into position on barges. Once the ring of cylinders formed a closed boundary, the interior was filled with inert material, and the island grew upward from the surface of the sea. 100,000 square meters of dry land created in the open Pearl River estuary in under 2 years without touching the ecology of the seabed below. The Chinese white dolphin was still present in the surrounding water when construction finished. That was not an accident. It was the result of an engineering method invented specifically to protect them. But nothing on this project arrived without a fight. Parts of the Hong Kong boundary crossing island, 150 hectares of newly reclaimed land sitting in open water northeast of Hong Kong International Airport, moved. The reclamation method used steel cells in a way that had not been done in Hong Kong before, and parts of the newly formed land shifted up to 6 or 7 meters from their intended position. Engineers worked through the problem and stabilized the island, but the delay cost months and money. Early site investigation drilling for the tunnel also encountered groundwater flows higher than the models had predicted, stopping work before the full geological picture had been assembled. The Pearl River estuary seabed kept producing surprises. Engineers kept solving them. The schedule kept slipping. The tunnel itself was the most technically demanding component of the entire crossing. 33 tunnel elements, each one 180 meters long, 40 meters wide, and 11.5 meters tall, and each one weighing 78,000 tons. These were not prefabricated components in any conventional sense. They were concrete structures the size of large buildings, manufactured in a purpose-built dry dock on shore, floated across open water on their own buoyancy, guided to their precise position on the seabed, and then deliberately sunk 40 meters to the bottom of the Pearl River estuary. Each element had to land at the correct angle, in the correct position, close enough to the previous element to be connected with a rubber gasket seal that would hold the full pressure of the Pearl River Delta outside for 120 years. A single failed seal in a tunnel, carrying 6 lanes of traffic 40 meters underwater, is not a maintenance problem. It is a catastrophe. The seabed sediment made everything harder. The Pearl River carries enormous quantities of silt, and silt does not wait for construction schedules. In the time between one tunnel element being positioned and the next element arriving to be connected to it, the seabed around the joint was already silting up. Engineers developed a dedicated sediment warning and forecasting system, a technology created specifically for this project that predicted silt accumulation rates and helped schedule immersions within windows where conditions were clean enough to make a watertight connection. Even with that system, the sediment was a constant adversary. The tunnel was built element by element across 5.664 kilometers of immersed section, each connection a high-stakes operation with no margin for error and no second chance. While the tunnel was being placed on the seabed, the viaduct was going up above the water. 22.9 kilometers of elevated highway deck, built from prefabricated concrete segments, assembled at sea and lifted into position by specialist crane vessels. The concrete volume consumed in bridge construction alone was 500,000 cubic meters. To produce it efficiently at the job site, engineers deployed floating concrete batching plants, mixing fresh concrete directly at sea rather than trying to transport it from shore. This was the first time that method had been used on a construction project in Hong Kong. It eliminated the logistical bottleneck of delivering perishable material across open water and gave engineers direct control over the quality of every pour. The bridge carries 3 cable-stayed spans across the deepest navigation channels, with the longest of the 3 reaching 458 meters between towers. The towers themselves rise in a form that references the fins of the Chinese white dolphin, the same species the island construction method had been designed to protect. That is not a coincidence. The design of this bridge held the ecology of the Pearl River estuary in mind. From the first drawing to the last weld, 400,000 tons of steel went into the complete structure across all sections. That is enough to build 60 Eiffel Towers. The scale does not become real until you stand at the edge of the estuary and look at it. The political engineering ran in parallel with the structural engineering for the entire 9 years of construction. 3 legal systems meant 3 sets of safety standards, 3 inspection regimes, and 3 sets of approval processes for every major design decision. Emergency response protocols had to work across jurisdictions where different agencies had different authorities. Environmental compliance had to satisfy 3 different governments with different regulations. The project authority, the Hong Kong-Zhuhai-Macau Bridge Authority, was a purpose-built entity created under the one country, two systems principle to coordinate a crossing that physically touched all 3 places simultaneously. It was a governance structure that had no precedent, managing an engineering project that had no precedent in a marine environment that produced surprises on a regular basis. The bridge was designed to last 120 years. To achieve that in the Pearl River estuary, where saltwater attacks concrete and steel at every surface every hour of every day, the material specification had to go far beyond anything in a standard highway code. The concrete mix was engineered for marine durability. The steel reinforcement was specified at grades that maximized corrosion resistance. The structural design was rated for a magnitude 8 earthquake, a category 16 typhoon, and the direct impact of a 300,000-ton vessel. These are not theoretical margins. Typhoons pass through this part of the South China Sea regularly. The Pearl River estuary sits within reach of the seismic zones of southern China. The design was built for the real conditions of the real place over a real century. Since opening on October 24, 2018, when President Xi Jinping inaugurated the crossing and the first vehicles drove across it the following morning, the bridge has already been tested by multiple major typhoons and stood without incident each time. The cameras mounted along the full length of the structure monitor every vehicle continuously, with fatigue detection systems that trigger an alert at the control center if a driver yawns more than 3 times in 20 seconds. A structure designed to survive earthquakes and typhoons watches out for tired drivers at 100 kilometers per hour. That is the scale of thinking that went into every layer of this project. On January 31st, 2025, the Zhuhai port recorded 156,000 passenger trips in a single day, a new record since opening. The estuary that kept Hong Kong and Zhuhai apart for the first 100 years of their modern existence now moves that volume of people across it on a single day. The 30-minute journey that replaced 4 hours of road travel or an hour by ferry has changed how people on both banks of the Pearl River think about what is near and what is far. More than 30 years passed between Gordon Wu's first sketch of this idea in 1983 and the moment the ribbon was cut in 2018. The ocean that separated Hong Kong, Zhuhai, and Macau is still there. It is still 55 kilometers wide and full of shipping traffic and subject to typhoons. 55 kilometers of bridge, island, and tunnel simply cross it now as if it were never a barrier at all. 3 governments built something together that none of them could have built alone, across water that actively resisted them at every stage, under a political arrangement that had never been tried at this scale, and they built it to last 120 years. They said it was impossible, then they built it anyway. That is what humans do at their best. Like, share, and subscribe for more.